So this lesson is going to be about how we do translations. Now, what a translation means in maths is fairly similar to what it means in a language context as well. So to translate in a language means to change the word from one language to another, but it keeps the meaning the same. So it's still the same thing, and the same thing in maths really. A translation in maths is where the shape stays the same orientation, it stays the same size. So everything about the shape stays the same except for the position. So it's about moving a shape but keeping it the same way up. Just like translations in language are changing the word, but it still stays the same meaning. So we describe a translation by using what's called a column vector. Now this will probably be new to you. It's not a coordinate, but it's written in curved brackets. But this time, instead of writing them alongside one another like you would with a coordinate, we write them on top of one another. So a column vector, because this is a column vertically, has two components. It has what we call the x component, the first value, and this tells you how many spaces you're going to the left or the right. And if it's negative, it goes to the left, and if it's positive, that value tells you how many spaces you're going to the right. And the bottom part of the column vector, which I've put a y, tells you how many units up or down you're going to move the shape. So again, if it's negative, it's going down, and if it's positive, it's going up. So for example, if you saw a column vector of 3, 2, what that actually means is you're going to move a shape 3 units to the right, or something 3 units to the right, and you're going to move it 2 units up. If you saw a column vector with something like -5, 0, what that means, the minus tells you that it's going to the left 5 units, and the 0 tells you that it's not going to go up or down, it's staying in line in terms of up or down movement. So what I've got on the grid is I've got a shape labelled O. This is what we're going to refer to as the object. Just like we have with our rotations and reflections, the object is the starting shape. And we've got 3 different examples I'm going to work through, and we're going to move the shape using these column vectors. So the first column vector is 6, 2. Now the way in which I do this is I always choose one point on the shape and I move that point, and then I draw the shape from that point as well. So I'm going to take the bottom left hand corner where the right angle is on this triangle, and I'm going to think about moving that shape. So the first vector I've got is 6, 2. That's telling me I'm going to go 6 squares to the right. So 1, 2, 3, 4, 5, 6. So I'm jumping 6 squares to the right, and then it tells me I'm going to move 2 squares up because it's positive. 1, 2. Now you might not need to draw these on once you're used to it, but hopefully you can see that that's the movement that that point has taken to get to its new position. And now what I have to do is be very careful to draw the shape from that point in exactly the same orientation that it was originally. So if you look, that was the bottom left hand corner of my right angled triangle. It's going to stay as my bottom left hand corner of my right angled triangle. And so there is my shape, and I'm just going to put an A inside that to denote that that's the shape after it's been translated by the column vector 6, 2. So just to remind you, it went 6 squares to the right, that was the 6, and then it went 2 squares up. Right, for B, we're going to use this column vector, and again we're going to go back to the original object to do the translation. So the first part tells me it's -3, which means I'm going 3 squares to the left. So just like a number line, negatives going down. So 1, 2, 3 squares, so that's the -3. And then the -6 tells me I'm going 6 squares down. So 1, 2, 3, 4, 5, 6. Let's put a -6 to denote what I've done. So that means I've taken the point of the bottom left-hand corner of O, 3 squares to the left, and then 6 squares down, and that's where it's landed. So I then again draw the shape, same orientation, same way up, so it's still the same size. And there is my shape, which is going to be labelled B. Okay. Final one then is C. Now C is a column vector of 9, 0. So that means it's going to go 9 squares to the right because it's positive, and it's going to go no squares up. So we're going back 1, 2, 3, 4, 5, 6. 7, 8, 9. Okay, and we don't need to move it up or down because it had a 0 for the y component. So again, same orientation, same way up, and there is my triangle, which I'm going to label with a C. So if you look on my grid, I've got 4 triangles now drawn. They're all the same way up because they've been translated. So translation means that the orientation stays the same, that your shape won't change in terms of it being reflected or rotated. It's going to stay the same way up, it's just being moved. And we move a translation using a column vector.